the ones on the back here, if we look at them, let's see, our number 11, we've got 125 on the left side, and we have 25 on the right side. Unfortunately, 125 is not a power of 25, okay? Because if we square 25, I think it's like 225, I think. So what we're going to have to do on this one is we have to rewrite both sides. We've got to rewrite both sides so that they have a common base. Anybody have any ideas what the common base may be on 11? 5. 5. So 5 cubed is 125, and 5 squared is 25. So then we've got 3 times y is equal to 2. So y is equal to 2/3. Now, when you're checking this, there's not more than one thing in the exponent, but your exponent is a fraction. So if you're trying to plug this back in to check, you do have to put the 2/3 in parentheses, or it's going to seem like it's not the correct answer. If you don't put the 2/3 in parentheses, what it does is the calculator follows order of operations. So what it's going to do is it's going to raise 125 to the second power, and then it's going to divide that number by 3, which is very different from raising 125 to the 2/3 power. Okay, so make sure you put parentheses around fractions when they're the exponents. Okay, number 12, we have 16 to the 3x is equal to 8 to the x plus 2. Now be very careful with this one, because 8 and 16 are very closely related, right? 8 times 2 is 16, but that's not what we're looking for. We're looking for an exponential relationship. So we need to write 16 and 8 so they have the same base. What base is that going to be? Base of 2, okay? Yes, 16 is also 4 squared, okay, but we can't write 8 so that it's a power of 4. So both of these have to be 2. The 16 is 2 to the 4th, and don't lose that 3x that was already there. 8 is 2 cubed. Don't lose the x plus 2 that was already there. So 4 times 3x is 12x. 3 times x plus 2 is 3x plus 6. Make sure you distribute it. Subtract 3 from both sides. 9x is equal to 6. Divide both sides by 9. X is equal to 2/3 again. Okay. 13. We've got 4 to the 3x is equal to 8 to the x minus 1. Again, be careful. You don't look at that as, well, 4 times 2 is 8. We've got to have the same base. So both of these are powers of 2. 4 is 2 squared. 8 is 2 cubed. So we have the same base on both sides. So we can set their exponents equal to each other. 2 times 3x is 6x. 3 times x minus 1 is 3x minus 3. Subtract the 3x from both sides. 3x is equal to negative 3. Divide by 3. X is equal to negative 1. Okay, 14. 81 is one base, and 1/3 is the other base. Now, here's the easiest way to look at this. So 1/3 is really easy. The 1/3 is really easy. It's 3 to the negative 1. Okay, 1/3 is 3 to the negative 1. So that should tell us that, well, we should be able to write 81 so that it has a base of 3. Because we can't break down 3 any further. So 81 is 3 to the 4th. Notice I have perfect squares, perfect cubes, and 4th powers up here beside the projector screen, so you can use those as a reference. So 4 times 2x plus 5 is 8x plus 20. Negative 1 times 2x is negative 2x. Subtract 8x from both sides. 20 is equal to negative 10x. Divide by negative 10. Negative 2 is equal to x. So, not that much more complicated. We've just got to think a little bit more. Because we have to rewrite both sides. Let's do a few more examples just to make sure that we've got it. Okay. 15. We've got a base of 8. We've got a base of 32. Guess what? Bases of 2 are very, very common in these problems. 8 is 2 cubed. 32 is 2 to the 5th. 3 times 2a minus 1 is 6a minus 3. 5 times 2a plus 1 is 10a plus 5. Bless you. Subtract 6a from both sides. Negative 3 is equal to 4a plus 5. Subtract 5 from both sides. Negative 8 is equal to 4a. Divide by 4. Negative 2 is equal to a. Number 16. 27 and 243. Okay, 3 cubed is 27. 3 to the 5th is 243. Y'all work on that one. Junior and Mr. Beaver, he's to see you in his office. So 3 times 2x is 6x. 5 times x minus 2 is 5x minus 10. Subtract 5x from both sides. X is equal to negative 10. All right, number 17. Number 17. So we've got 64 and we've got 4. But before we deal with that part, let's deal with the fact that we have the 2 4s on the right side. So we need to combine those first. So we add their exponents. The first one doesn't have an exponent, but remember that's 4 to the 1st. So on the right side, when we add those together, we're going to get 4x plus 1, or 1 plus 4x. I like the variable to come first. Okay, now let's rewrite it so they have the same base. 64 is 4 cubed. So we don't have to rewrite both sides in this case. We just had to combine on the right side. So 3 is equal to 4x plus 1. Subtract 1. 2 is equal to 4x. Divide by 4. So 1/2 is equal to x. Number 18. We've got 2 9s on the left side, so we need to combine those. Let's add their exponents. 2x plus 4 plus 2x. Can we go ahead and rewrite the right side? What would 1 over 81 be? So it has a base of 9. 9 to the negative second, because 9 squared is 81, but it's in the denominator. So 2x plus 4 plus 2x is equal to 4x plus 4, and that's equal to negative 2. Subtract 4 from both sides, we get negative 6. Divide by 4, x is equal to negative 3 over 2. Okay, almost done. 2 more examples. Make sure we've got it all. 19 and 20 here. Ooh, got a lot going on with these. All right, so we have multiple terms on the right side, but they don't have the same base right now. So we got to fix that problem first before we can put them together. We got to fix that problem first before we can put them together. So, can we write them so that they have the same base? Yeah, base of 7. So it looks like this whole thing's going to need a base of 7. So let's go ahead and fix that left side too, right? That would be 7 to the negative 1 is equal to 7 squared to the x minus 5 times 7 to the x minus 9. You got to combine that stuff on the right side first. Can't just set the exponents equal to each other yet. We need to distribute that 2x minus 10. And then we can add those exponents since we're multiplying their bases. So 2x plus x is 3x. Negative 10 plus negative 9 is negative 19. Then we can set those exponents equal to each other. Negative 1 is equal to 3x minus 19. Add 19 to both sides. 18 is equal to 3x. Divide by 3. 6 is equal to x. All right, one last one. 4 to the 2x times 1 over 16 is equal to 4 to the 6x plus 18. So it looks like everybody needs a base of 4. 1 over 16 is 4 to the negative 2. Multiplying the bases, so we add their exponents. 2x plus negative 2 is 2x minus 2. Set those exponents equal to each other. 2x minus 2 equal to 6x plus 18. Subtract the 2x. Subtract the 18. Negative 20 is equal to 4x. Divide by 4. Negative 5 is equal to x.